In this video, we're going to circle back around actually to some of the fundamentals that we really have only alluded to in the previous two videos. So the overall topic of this discussion is how to use the root 3 for PE questions dealing with single-phase loads on three-phase systems. So we will only frame our discussion in the circumstance of a single-phase load on a three-phase system, and we're going to assume balanced conditions. And so in working through this, we're going to answer the question, what is the significance of identifying the source for our root 3 calculations? Now that's not the only thing that's significant, or even the absolutely primary thing that's significant. But what we're going to see is, as we work through it, it's going to sort of help us get a roadmap together when we work from the source down. And it's very easy to see that there are only two constructions to work through when thinking about how the source affects the root 3 calculations. We only have two types of sources. We have a delta source and a y source. And because this discussion divides so conveniently along just those two paths, we're going to use a flow chart to demonstrate this. So for any calculation involving three-phase voltage and current, we need to ask ourselves, what is the source? Let's start off in saying that we have a circumstance where we have a delta source. Once we identify a delta source, we no longer need to worry or concern ourselves with the voltage that was supplied in the problem. And what I mean by this is line voltage and phase voltage really match and are the same. And to see this more clearly, please refer to our previous videos, because we did sort of get into this on a more detailed level, demonstrating how line voltage and phase voltage match with a delta source. That's the first video. You can see in this diagram that there is no difference between line and phase voltage. It's all the same. Okay, the next question we ask, now that we understand the load, and we also, or rather now that we understand the source, and now that we're not concerned with voltage and we're concerned with current, is what is the load? Now we said that this is going to be a single-phase load on a three-phase system, and so we can identify it as that. So now that we have voltage set, we're looking to understand the current better. And in order to understand the current better, we ask ourselves this question. Does the current given in the particular problem match the way the load is connected? And this is where the root 3 is really going to come into play, because what we're really looking to answer is just what I wrote there. Is the current that was provided to you by the problem really the current you need for your final calculation? And so if we can answer yes to that first question, which is, does the current given in the problem match the way the load is connected? If it's yes, and by that I mean if the load is connected line to line and you're provided with line current, then you know that the current given is the current you need to solve the problem in your final equation. Now what if it doesn't? What that means is, let's say the load was connected line to phase and you were given line current. That means that the current you were given is not the current that you need to solve the problem, and something needs to be done to that current in order to make it applicable to your final power calculation. And this is where the root 3 is going to come in. We're going to use the root 3 to work on that current to get it to the place we need to actually solve finally. So with these two distinctions in mind, if the current provided is the current we're going to use in our final situation, being that it's the current that is identified by the way that the load is connected, then no root 3 is needed. We have all the information we need to perform our calculations. If not, then we need to apply the root 3 in our particular calculations. And where would we apply that root 3? We wouldn't apply it in our voltage understandings. It would reside in our current calculations. And this would be the current calculation very clearly demonstrated. And once we apply that math there, then we can have the the load current and the load voltage so that we can solve for any calculation regarding three-phase voltage and currents at the load. Okay, so that wraps up the delta side of our flowchart. Now let's move over to the Y side. So if we have a Y source, we do not need to wonder if the current is phase or line current provided by the problem. So you can see there's a difference here. On the delta side, we had the voltage that we didn't need to wonder about, and on the Y side now, we don't have to wonder about the current. This was dealt with in detail in our second video, and I'm showing you a circuit diagram here just to refresh your memory. And here we can see that line current and phase current match. They're the exact same. Okay, moving now along our flowchart, we now are going to be asking questions of the voltage. The voltage is the thing we're going to need to work on now. So we ask ourselves, what is the load? We remember that we're dealing with single-phase load on a three-phase system. And we're going to ask, yet again, a similar question that we did on the delta side. And we're going to ask, does the voltage given in the problem match the way the load is connected? Now, the only difference is before we were asking, does the current match? And now we're asking, does the voltage match? Same issue. Is the voltage supplied in the problem line voltage? And if so, if the load is connected line to line, then there is no need to use the root 3. As you saw before, we were questioning whether the current given is the current you need. Now we are questioning whether the voltage given is the voltage you need to solve the problem. So really, if you see the distinction between our two sources here, it's one we're sure of the current, the other we're sure of the voltage. And the same consequence applies. If it does match, then no root 3 is necessary to make the voltage applicable to our final calculations. And if it doesn't match, meaning if we were supplied with line voltage and the load is connected line to neutral, then we're going to need to use the root 3 on the voltage to get a final voltage product that will allow us to do our calculation. Speaking of calculation, let me give you the formulas right here just to show it very clearly.